Good afternoon. Let us get started. Okay, today we will look at the binomial expansion. Now, what the binomial expansion is you will have a bracket like this to the power of n, and then you have two terms inside. And we want to expand this. When n is a small number, it's pretty easy to do. Let's say if, for example, I say a plus b to the power of 2, you know that this is just a plus b multiplied by a plus b, and then you can multiply this out, and you'll get a squared plus 2ab plus b squared. That is very simple to do and doesn't take you a long time. But when n gets bigger, we have a plus b to the power of 3. If you were to do this the normal way, you would say a plus b, and then a plus b. Then to do this, you would multiply the first two brackets, second two, you get an answer here, and then the three terms that you have here, you would have to multiply out like that, and then you get one final answer. So with 3, you can see it's already becoming quite tedious to do. So what we do is we introduce some techniques that are easier to use or easier to do than the usual way of expanding it. Now the first one we look at is what is known as Pascal's triangle. And what Pascal's triangle gives us is a triangle with coefficients in the expansion. Now creating or writing this Pascal's triangle is very easy to do. You start at the top, there's a 1, then the next level you have a 1 and a 1 as well. Then the next level at the end you will always have a 1, but this term here I get it by adding those two terms. So I always put a 1 at the end, then the term that goes there is 1 plus 2, which is 3, and then 2 plus 1 is 3. Then to get the next level, I put 1s at the end, then I add those two together. 3 plus 1 is 4. Then these two, I add them together, I get 6. Those two, I add them together, I get 4. So I always put 1s at the end, add these two together, they give me 5. Add those two together, they give me 10. Those two together, they give me 10. Those give me 5, and then there's 1s at the end. So I can continue indefinitely, and this is what is known as Pascal's triangle. Now, why is this triangle useful, or what do I do with this triangle? What I can do with this triangle is these numbers here at each level, they give me the coefficients in the binomial expansion. So if I have this a plus b to the power of 2, we did this, we said that this is a squared plus 2ab plus b squared. So what you will notice here, my expansion, if I just write it again, this is a squared plus 2ab plus b squared. The coefficients here, I have 1, I have 2, and then I have 1. And then when I compare this with my triangle, here I have 1, I have 2, and then I have 1 over there. So this is the level when n is equal to 2. Now when n is equal to 3, if I was to expand this, a plus b to the power of 3, like I said, this is a plus b multiplied by a plus b, then I'll multiply this again by another a plus b. So this one over here, the first two terms, we've multiplied them over here, and we got this. Got a squared plus 2ab plus b squared, and then now we multiplied by a plus b. So multiplying our brackets out like that, and then the b squared as well. Let's see what we end up with. I have a squared times a, this is a cubed, a squared times b, this is a squared b. I have 2ab times a, this is 2a squared b, 2a squared, 2ab times b, this is 2ab squared, and then I have b squared times a, which is just a b squared, and then b squared times b, which is b to the power of 3. Then collecting my like terms, I can see these two are like terms, a squared b. I have 3 of them. I have a cubed plus 3a squared b, and then these two are also like terms. So 2ab squared plus ab squared, this gives me 3a b squared, and then b squared doesn't have any like terms. Now when I look at the coefficients here, I have 1, I have 3, I have 3, and I have 1. And then if I go back to compare with my triangle, you can see I have 1, I have 3, I have 3, and I have 1. So this triangle, what it does is it gives you the coefficients in the expansion. So if I wanted to work out a plus b to the power of 10, for example, all I would need to do is continue my triangle until I get to level 10. So this level 2, level 3, 4, 5, 6, 7, 8, 9, 10, and then I would take the coefficients. Then I just have to look at what is happening to the exponents of a and b. If I look at this one over here, I start with a, then it goes a squared, then a to the power of 1. When the power is 1, we don't even need to write it. And then the last one, there's no a, that means it's a to the power of 0. So the powers of a are decreasing, while the powers of b, here I don't have b, that means it's b to the power of 0. Then b to the power of 1, and the exponent is 1, we don't need to write it. And then I have b to the power of 2, and then b to the power of 0. So you'll see that the powers of a and b always add up to 3, which is what I was, that was then my exponent of the binomial. So here I have a to the power of 3, b to the power of 0. 3 plus 0 is 3. Here I have a to the power of 2, b to the power of 1, 2 plus 1 is 3. Over here, I have a to the power of 1, b to the power of 2, 1 plus 2 is 3. Here I have a to the power of 0. A to the power of 0 we know is 1, so that's why you cannot see it. And 0 plus 3 is 3. So if I know what the coefficients are, and I know the pattern of what is happening to the exponents of a and b, I can work out just about any expansion. So let's try using the triangle to do an expansion. Let's say I ask you, what is x plus 1 to the power of 4? So first thing you should do is identify what your a is. So here a is x, and then b is 1. Then you go to your triangle, you go to level 4, and it's here. So I have 1, 4, 6, 4, and 1. So those are my coefficients. Then I will write those down. So I have 1, 4, 6, 4, and 1. Then here I will multiply each of these coefficients by the powers of a and b. The powers of a are decreasing starting from 4, and then the powers of b are increasing starting from 0. So the first one, I will say 1 multiplied by my a, which is x to the power of 4, and then my b, which is 1 to the power of 0. Notice that these two add up to 0. Then the second coefficient is 4. Then I put my a, which is x to the power of 3. It must decrease, goes 4, then 3. And then I have 1 to the power of 1. The powers of my b, which is equal to 1, are increasing. They start from 0, now it's 1. Then I continue. My next coefficient is 6. Then I have my a, which is x to the power of 2. So 4, 3, now it's 2. Then my b, which is 1, and this is 2. So the powers of my b are increasing. So I have 0, I have 1, and then I have 2. And all the time, these exponents here, 4 and 0, they add up to 4. 3 and 1, they add up to 4. 2 and 2, they add up to 4. And I'm just using these coefficients that I got from my triangle. And the next one, I have 4. My a, which is x to the power of 1, multiply this by my b to the power of 3. And then the last one in the expansion is just 1 times my a, which is x to the power of 0, multiplied by my b, which is 1 to the power of 4. Then what I do here is now just simplify what I have. So for the first one, I have 1 times x to the power of 4 times 1. This is just x to the power of 4. Then the second one, I have 4 times x to the power of 3, which is x to the power of 4x to the power of 3 times 1. This is just 4x to the power of 3. And then I have 6x squared times 1, which is just 6x squared. And then I have 4x, so it's 4x times 1 cubed, which is just 1. So this is 4x, and then my last term is just 1, because this is 1 times 1 times 1, which gives me 1. So the expansion of x plus 1 to the power of 4 is equal to all this. And this is much shorter than you writing the 4 brackets. You multiply the first two, you get an answer, multiply that with the third bracket, get an answer, and then multiply that with the fourth bracket to get your final answer. Okay, so this doesn't take you very long. So all you need to do is draw your triangle. The triangle is very simple to do. 1 is at the top, then you put 1s at the ends. Then 1 at the end, you add these two together, they give you 2. You must have a 1 at the end. The level always starts with 1, then you add those two, this gives me 3. You add those two, this gives me 3. Then I always end the level with 1. So again, I have 1, add those two together, this gives me 4. Add those two together, this gives me 6. Add those two together, this gives me 4, and my level always ends with 1. Every level starts and ends with a 1. And you can see this is a triangle. So that's why it is called Pascal's triangle. Okay, so you can do this till whatever level you're looking for. So if I want a plus b to the power of n, to the power of 2, sorry, this is the level when n is equal to 2. This is when n is equal to 3, when n is equal to 4. So you look at the first number after the 1. This is power 2, power 3, power 4, and then power 5 will continue like that. Let's look at another example. Let's say I have 1 minus x to the power of 4. Okay, so again, you first have to decide what is your A and what is your B. Now remember, our formula is for a binomial sum. That means it must be addition. You're adding A and B. Here I have a difference. So first thing I need to do is rewrite it as a sum. So when I do that, I have 1 plus negative x to the power of 4. Now it is in the form A plus B to the power of n, because the binomial expansion works for a sum, not for a difference. So now that I've written it like this, I can say that my A is 1 and my B is negative x. Okay, then I just go to the fourth level on my Pascal's triangle, which is this one here. So these numbers here, 1, 4, 6, 4, and 1. Those are my coefficients. So you can just take note of them. It's 1, 4, 6, 4, and 1. These are my coefficients. So we said we write down the first coefficient as 1. Then I multiplied by A, which is 1. And then the powers of A are decreasing, starting with 4. So I have 4. And then my B, this is minus x to the power of 0. And these two must always add up to your n. In this case, n is 4, so 4 plus 0 is equal to 4. Then the second one, my coefficient is 4, so I have 4. Then my A is 1. The power should decrease at 3. And then my B minus x to the power of 1. And then the next coefficient is 6. I have 6. I have 1 to the power of 2. So you can see 4, 3, 2. Those are decreasing. And then I have minus x to the power of 2. These are increasing. 0, 1, 2. And then the next coefficient is 4. I have 1 to the power of 1 minus x to the power of 3. And then finally I have my last coefficient, which is 1. And then 1 to the power of 0 minus x to the power of 4.
Miss,
Yeah,
Miss,
yeah.
how do you got that exponents?
Which ones?
Like those ones that are decreasing, like from
This
4,
4.
3, 2, and 1. Yes, the exponents.
What? It's a pattern that you must take note of. You start with 4 because you are expanding this to the power of 4. Okay, so that tells
Okay.
you where I start. So I'm not going to start 5, 4, 3, 2, 1. I must always start 4. Then the powers of A are decreasing. You start 4, 3, 2, 1, 0. The powers of B are increasing. 0, 1, 2, 3, 4.
Okay, thank you, Miss.
All right. So now that I have this, what I do is I simplify this as far as possible. If I look at the first term, this I just need to work it out. I have 1 times 1 to the power of 4 times minus x to the power of 0, which is equal to 1. So I have 1 times 1 times 1. This gives me 1. And then I have 4 times I have 4 times 1 times minus x to the power of 1. This will give me minus 4x. Okay, then I have 6. I'm over here now. I have 6 times 1 times minus x squared. Now minus x squared, this is just the same as x squared because it's negative x times negative x. Two negatives, when you multiply them, your answer is positive. So this will become x squared. This is equal to 1, so I have 6 times x squared, which is just positive 6x squared. And then the next one, I have 4 times 1, which is just 4. And then here I have negative x to the power of 3. This means negative x times negative x times negative x. I have 3 negative numbers multiplying. My answer will be negative. Because the first 2 numbers multiply, it gives me a positive. Then I multiply with the last negative, it gives me a negative. So this is negative 4x cubed. And then the last term, I have 1 times 1 times negative x to the power of 4. This negative x to the power of 4, I have 4 negative numbers multiplying. This means my answer will be positive, so I will get x to the power of 4. So you can see what is happening to the powers of x. We start with x to the power of 0, x to the power of 1, x to the power of 2, x to the power of 3, and then x to the power of 4. So whenever you're doing an expansion like this, very important, you need to work out what is your A, what is your B, and then you follow the pattern as I have done. So let's look at one that is a little bit different. Let's say I have 2t plus 3 over t to the power of 4. So again, this I will do it in the same way. My exponent is 4, so that means I go to level 4 on my triangle, which is that one, where the second number is 4. Then what I do is I will take note of these coefficients. I have 1, then I have 4, 6, 4, and 1. Then I will put my A to the power of 4, B to the power of 0, A to the power of 3, B to the power of 1, and so on. So here, my A is the first one, so this is 2 to the power of t, and then my B here is 3 over t. So identify what is your A and what is your B, and make sure what is separating them is a sum, because this works for a binomial sum, not a difference. If you have a subtraction between them, what you should do is rewrite it like I did with the previous one. So now that I know what my A and B are, what I do now is I will multiply the coefficients with the powers of A and B increasing and decreasing. So my first coefficient is 1, then I take my A, which is 2t, just the way it is, and then the exponent is 4. Then I write my B to the power of 0. So remember, these two exponents must add up to 4. So I have 4 plus 0. This gives me this 4 I have over here. My A, the exponents must be decreasing. My B, the exponents must be increasing until I get to this number that I have over here. So my next coefficient, this was 4. Then I write my A, this is 2t. The power should decrease. The powers of B should increase. Then I continue with my next coefficient, which is 6. The powers of A should decrease. The powers of B should increase. In the next coefficient, the powers of A should decrease. The power of B should increase. And then the last one, coefficient is 1. The power of A should decrease, and the power of B should increase. So looking at this, you can see this represents my A. This 2t is my A. The powers went 4, 3, 2, 1, 0. This 3 over t, this represents my B. The powers must increase. So 0, 1, 2, 3, and 4. And over here, I have my coefficients, which I got from the triangle. It was 1, 4, 6, 4, and 1. So all this, I will then simplify it. Now you'll notice when I'm multiplying these two, this t, the first t is in the numerator, and this one is in the denominator. There will be some cancelling that will take place. But when I first rewrite them, I must make sure that the exponents of a and b must always add up to 4. Okay, so let us simplify. So for the first one, I get 2 to the power of 4 times t to the power of 4, which is 16 t to the power of 4. Let's see that one. So this is equal to 1, because anything except 0 to the power of 0 is equal to 1. So I have 1 times 2t to the power of 4 times 1. Then I'm just left with 2t to the power of 4. Then remember your laws of indices. If you have a product raised to an exponent, you can distribute the exponent. So it's 2 to the power of 4, t to the power of 4, which is 16 t to the power of 4. Then the second one, yeah.
Miss, I think I have a problem with the brackets, how you multiply them out. Which ones do you do first? Do you do the number first, or do you do the brackets first and then multiply with the number that's outside?
At which step are you talking about? You mean how I got the
Mm.
16t to the power of 4? Or
Oh no,
which
miss.
one? Which
Just
one?
scroll back a bit up. Just the, yeah, here.
Yeah,
At 1t
this one?
raised to 4.
Yeah,
Just how do you multiply out all those brackets?
use BODMAS. You must work out what's in the brackets first. Here, if this number was, let's say, 5, I would not say 5 must go inside the bracket and then I square everything. That's not how BODMAS works. Sorry, the thing, I don't know why today it's acting up. But if, for example, let me illustrate something. If I have 2 times 3 squared, this is not the same as 6 squared. It's not. I must first work out 3 squared and then multiply the answer by 2. So that's the same
Okay,
principle I'm using here. Yeah?
now for this, in this case, miss, we have
Mm-hmm.
brackets. That's
Yeah.
where the confusion is. So
What
first
is
we
the,
work out the brackets and then we use for the part that's outside.
here I have 3, these brackets means everything is multiplying. So if I tell you to multiply 2 times 3 times 4, whether you say 2 times 3 and then multiply that by 4, or you say 3 times 4 and then multiply it by 2, your answer will be exactly the same. I don't know
Oh,
if
okay.
that's
Thank you, miss.
okay. So with a product, it doesn't matter how you multiply them. You just shouldn't do this. Let me just go here. If, okay, this is to note. If I say 2 times 3 times 4, this is not, I don't do this. That is not correct. You can try this on your calculator. You will not say this is 6 times 8, which is 48, which I'm sure you know 2 times 3 times 4 is not equal to 48. Okay, it's 2 times 3, which is 6. 6 times 4 is 24. Okay, or I could say 4 times 3 is 12. 12 times 2 is 24. That's how you multiply. The distribution happens when I have a sum. I think you'll, so this one, not all of it is, yeah, all of this is wrong. The distribution I
Okay,
did with my arrows was if I had something like this, then I will distribute. This one is correct. With a multiplication, you say first one times the second one times the third one, like that. Okay, so let's finish this one off. So here, the 16t to the power of 4, I just worked out this one. 1 is just 1. And then 2t to the power of 4, that's 16t to the power of 4. And then 3 over t to the power of 0 is equal to 1. So this is equal to 1. So I have 1 times this times 1, which gives me 16t to the power of 4. Then I look at my second term. Here I have 4. And this term over here, I should work it out before I multiply with the 4. So what I will have there, this is 2t to the power of 3. This means 2 to the power of 3, which is 8, times t to the power of 3. So this is 8t to the power of 3. And then 3 over t to the power of 1 is just 3 over t. So the numbers I will multiply are 4 times 8 times 3. So let me write that down. So I have 4, then I have 8t cubed, and then I have 3 over t. That is my second term. And then the third term is this one over here. The 6, what's here, I need to simplify it. 2t squared, it's 2 to the power of 2, which is 4, and then t to the power of 2, which is t squared. So what I have over there, this is 2t to the power of 2. And then this 3 over t to the power of 2, that is just 9 over t to the power of 2. So this one is 9 over t to the power of 2. So that's what I'll write there. So my coefficient 6 will multiply by 4. That should be 4 up there. Multiply by 4 t squared multiplied by 9 over t squared. And then the fourth term, here I have 2t to the power of 1, which is just 2t, and then 3 over t to the power of 3. This will be 3 to the power of 3 over t to the power of 3, which will give me this. This is 2t, and this gives me 27 over t to the power of 3. So what I will then write here, this is 4 times 2t times 27 over t to the power of 3. And then my last term here, this is 1, 2 to the power of t, 2t to the power of 0. This is just equal to 1. So I have 1 times 3 to the power of 4 over t to the power of 4, which is just 81 over t to the power of 4. So here I have 81 over t to the power of 4. And then I simplify each of these where possible. So this is equal to the first term, 16t to the power of 4. I cannot simplify it any further, so it is just 16t t to the power of 4. And then the second one, I have 8 times 4 times 3 that you work out on your calculator. You should get 96. And then look at your powers of t. In the numerator, I have t to the power of 3. And then in the denominator, I have t to the power of 1. You subtract the exponents, you end up with t to the power of 2. And then do the same thing with the next one. 6 times 4 times 9. Those are the numbers. All of them are in the numerator, so I can just multiply them. This gives me 216. And then I look at my t. Here I have t squared in the numerator, and then in the denominator I have t squared. I'll say 2 minus 2, this is 0. T to the power of 0 is just equal to 1. So this term that I have here, 216, will not have a t. Then the next one, I have 4 times 2 times 27. This is also equal to 216. And then I look at my t's. In the numerator, I have t to the power of 1. In the denominator, I have t to the power of 3. So I say 1 minus 3. This is t to the power of negative 2, which I can write over t squared. I can rewrite it in the denominator so that it is positive. And then the last one, I cannot simplify it any further, so that remains as it is. So this is the binomial expansion. Now you'll notice that this term here doesn't have a t. All the others have t's. The powers of t are still decreasing, even though it's not in the same order, or it's not in the same way that they were decreasing with the other one, where it's 4, 3, 2, 1. And the reason is because of the question that we started with. We started here. You can see my A and B have powers of t, so that will affect their overall power. What I should see increasing or decreasing is at this stage over here, where it's 4, 3, 2, 1, 0, 0, 1, 2, 3, 4. My coefficients 1, 4, 6, 4, and 1. Just like that. Is that one fine? I hope your silence means it is fine. Now with the Pascal's triangle, the only way to really get the hang of it is to practice it. Okay, you need to practice. There are more questions in the notes. You can take a look at those. There are even more examples that I didn't go over now that you can take a look at, and that is the way you'll get the hang of it. Now Pascal's triangle is pretty easy if your value of n is a small number. Like here we've been using 4 a lot. 5 is easy. But now what if I ask you to the power of 20? Let's say I say expand this x plus 1 to the power of 20. In order to use Pascal's triangle, you must write this triangle, and it must have 20 levels, or you must end at level 20. Pascal's triangle in itself is not a difficult triangle to construct, but it will take you a very long time. And there is a shorter way of working out what this expansion is without drawing the entire Pascal's triangle. And that is what we call the binomial theorem. Now, before we look at the binomial theorem, I want to introduce a new mathematical operation that we have, which is known as factorial. So you know division, that's a mathematical operation. You know addition, you know square root, you know logs. Those are all mathematical operations. This one is also a mathematical operation. We write it like this. So we say n factorial. we represent it using an exclamation mark. Now what factorial means is very simple. If I say find n factorial, this means you take n, then you multiply it by n minus 1, then you multiply it by n minus 2, then you multiply it by n minus 3, n minus 4, and so on until you get to 2 and then 1. So we look at an example. Let's say 5 factorial. 5 factorial, this is 5 times 4 times 3 times 2 times 1, which is equal to 120. That's what 5 factorial means. If I say 10 factorial, this is 10 times 9 times 8, and you keep going until eventually you say times 2 times 1, and this should give you 3,628,800. That is what factorial means. You start at the number I've given you, multiply it with 1 less than the number, 2 less than the number, 3 less than the number, until you get to 2 and 1, and then you stop. You don't multiply it by 0, because as soon as you multiply it by 0, the final answer is just going to be 0. So you stop at 1. Now with factorial, you should note that 0 factorial, this is by definition equal to 1. So 0 factorial is equal to 1. It's a definition. Then 1 factorial is also equal to 1. Okay, so you can add factorials, you can multiply them. I could ask you something like this: 2 plus 3 factorial. Factorial does not distribute. So what I need to do is work out what I have inside the brackets first. So this is just 5 factorial, which is equal to 120. I could also divide factorials. Let's say I say 6 factorial divided by 3 factorial. Now here, I don't say this is equal to 2 factorial. This is 6 factorial over 3 factorial. And 6 factorial, this is 6 times 5 times 4 times 3 times 2 times 1. So the 1 cannot fit there, but not writing the 1 doesn't change anything. And then 3 factorial, we know this is 3 times 2 times 1. Now you can see over here I have 3 times 2 times 1, and then here I have 3 times 2 times 1. Those two can cancel. Then what I'm left with, this is 6 times 5 times 4, which is 30 times 4. This gives me 120. Is that right? Okay. And similarly, I could have done it this way. I say 6 factorial over 3 factorial. This is 6 times 5 times 4 times 3 factorial. Now 3 factorial represents this part over here, 3 times 2 times 1, and then I divide by 3 factorial. You can see the 3 factorials cancel, and then I will still get my 120. So if I have 10 factorial divided by 8 factorial, this is 10 times 9. Then instead of writing 8 times 7 times 6 times 5 all the way till 1, I just represent that with 8 factorial, because that 8 times 7 times 6 and so on represents 8 factorial. And then in the denominator, I still have 8 factorial, and those two cancel out, and then this is equal to 90. Then also, instead of me working this out, then working that out and then dividing, rewriting them and seeing what can cancel is much easier to do. So we could say, what if I have 5 factorial, 4 factorial over 2 factorial? Okay, let me say 3 factorial there as well. So when the factorials are next to each other like that, it means they're multiplying. So I have 5 factorial times 4 factorial divided by 2 factorial times 3 factorial. So what I do is I will write 5 factorial as 5 times 4 times 3 factorial, because I wanted to cancel with that one in the denominator. And then 4 factorial, this one now, I'll write it as 4 times 3 times 2 factorial, because I wanted to cancel with that one over there. Then in my denominator, I have 2 factorial, 3 factorial. You see this 3 factorial cancels with that one. This 2 factorial cancels with that. Then I'm left with 5 times 4 times 4 times 3. And then this, you work it out, 5 times 4 times 4 times 3, you get 240. So that is how factorial works. So it's just another mathematical operation that you can now use. It's represented using an exclamation mark. So on your calculator, when you see that exclamation mark, that means it is the factorial symbol. Now, in order to use the binomial theorem, we will make use of this factorial operation. Now, what we will do with it is we will use what we call combinations. Combinations. Now, maybe you've heard of permutations and combinations. Now, permutations and combinations, these are ways of arranging things, okay, and choosing things. Now, with a permutation, you can think of 3 people standing in a line. So you have person A, person B, and person C. Okay, you have person A, person B, and person C. And with a permutation, you ask yourself, in how many different ways can I arrange these people? So you can say, okay, A, you stand there, B and C there. Then I could also arrange them as A, C, B. I could say A, you stand in the middle now. So I have B, A, C, then C, A, B, and then A comes last, so I have BC, C, B, A. So here there are 6 ways of arranging 3 people. So 3 people are standing in a line. There's 6 ways. There's only 6 possible ways that they could stand in that line. So this is a permutation where the order matters. Then with a combination, order does not matter, because here when I have A first, in this second scenario, A is still first, but the order is not the same. This time B is third and C is second. So these 2 are considered as different. But with a combination, what we do is we just choose, where the order doesn't matter. With a combination, we would say that all 6 of these are the same. So I don't want to go too much into that, because that's not part of what we are doing. We are just making use of a combination. Now, a combination, what we do with a combination is we ask ourselves, in how many ways can I choose a number out of a given number? So let's say I have 3 people, okay? I'm interviewing them for a job. I'm going to pick 2 people. So I want to see, in how many different ways can I pick those 2 people to give the job, okay? So I could pick either AB, I can pick AC, I could pick BC, or I could, is that it? I pick AB, I pick AC, I pick BC, and I pick CA. No, it's the same. Sorry. I think those are the only ways of choosing 2 people. Okay, so here, like I was saying, if somebody said, what if you pick CA? Picking CA, I still picked A and C. So CA is exactly the same as AC. So with permutations, the order that you pick them in matters, but with combinations, the order that you pick them in does not matter. Okay, so here what I'm doing is out of 3 people, I want to choose 2 people, and then my answer is 3 because there are only 3 ways that I can pick 2 people out of the 3 people. Okay, so that's what a combination is. You're choosing out of n people or n items, you're picking a select number, and the answer over here is the different ways that you can pick that number that you want to pick out of the total. Okay, so this 3 choose 2, you write it like this, 3 choose 2, and this is just equal to 3. So when you see this NR, this is the same as out of n items, n people, choose R, and then tell me how many different ways can you choose R people out of n people. Okay, and by definition of this, n choose R, this is equal to n factorial over, this is equal to n minus R factorial over R factorial. So that's why we learned about the factorial and what it is. So if I use the example that I gave, I have 3 people and I want to choose 2 people. This is 3 factorial divided by 3 minus 2 factorial multiplied by 2 factorial. So we can work this out. This is 3 factorial. In my denominator, I have 3 minus 2, which is 1. So I have 1 factorial and then 2 factorial. This is 3 factorial. Sorry, let me remove the factorial. So 3 factorial, I can write it as 3 times 2 factorial because 2 factorial represents 2 times 1. And then 1 factorial is just 1 and then 2 factorial. Then these two cancel and you can see that there is 3 ways of choosing 2 people out of 3. Then I could also ask, what is 3 choose 1? Now this one is obvious. If I have 3 people and I want to choose 1 person, there's 3 ways that I can choose 1 person out of the 3. Either I pick the first one, the second one, or the third one. Those are the 3 different ways. But we can also calculate this and say this is 3 choose 1, and this is equal to 3 factorial over 3 minus 1 factorial multiplied by 1 factorial. So this is 3 factorial over 2 factorial times 1 factorial. 3 factorial, I can write it as 3 times 2 factorial, and then 2 factorial plus 2 factorial, 1 factorial is equal to 1. So those two cancel, and you can see that my answer is 3, like we said. And here you will notice that if I have 3 people and I choose 2, my answer was the same as when I had 3 people and I choose 1. And that is because if you have 3 people and you choose 1 person, the 2 people that you are not choosing are in a way being chosen. So that is why the number of ways of choosing 2 people out of 3 is the same as choosing 1 person out of 3. Okay, let's look at one more example. Let's say I have 7 choose 2. So 7 choose 2, I have 7 people and I want to choose 2 people out of that 7. 7 is still a pretty small number, so you could probably work it out. But the shorter way of doing it, this is just 7 factorial divided by 7 minus 2 factorial. Then you multiply this by 2 factorial. So what I have here, this is 7 factorial. Then in the denominator, I have 7 minus 2 factorial, which is 5 factorial. And then 2 factorial is just 2 factorial. So simplifying this is 7 factorial. 7 times 6 times 5 factorial. And then divide this by 5 factorial, 2 factorial. Those two cancel. Then I have 7 times 6. 2 factorial is just 2 times 1, which is 2. Then I can cancel. This will give me 21. So if I have 7 people and I want to choose 2 people out of the 7, there's 21 different ways that I can do that. So you can try it, put 7 objects and then count the different ways of picking 2 out of those 7. You will see that there's only 21 different ways to do that. Now we will use this choosing to work out a binomial expansion. So I'll just write down the formula for the binomial expansion. It's a plus b to the power of n. This is equal to, remember, sigma, then k is equal to 0. Then we end at n. Then I have n, choose k, a to the power of n minus k, b to the power of k. So if you remember what we did in series, this is our starting point, this is our end point, this is what we introduced today on choosing, and you can see over here my powers of a are decreasing because I start with n minus 0, which is n, then n minus 1, then n minus 2, and so on until I get to n minus n, which is 0. Here my powers of b are increasing. I start with 0, then the next one will be 1, then 2, then 3, and so on. So what I would like you to do is try and write this expansion, maybe put a number over here, or try and use this formula to work out x plus y to the power of 5. So here my n is equal to 5. K will be 0, 1, 2, 3, 4, and 5. So try and use this formula to expand that. Okay, so we'll stop here for today. Hopefully by tomorrow we should be done with this chapter. Then we can start on trigonometry next week. I think we will have to just spend the entire week on trigonometry because it's not a very short topic. For the test 3, we will probably have to have it as a quiz, not a longer quiz, but a quiz online. That is so that everybody can know their marks before the supplementary test, so that you know if you have to write the supplementary test or not. It'll cover the same content that test 3 is supposed to cover, except that it will be in the form of a quiz and not one where you write and upload like you did for test 2. The supplementary test will be one where you scan and upload. So make sure you avoid writing the supplementary test if you can. Okay, so I'll stop there for today. Do you have any questions?
I have a question, ma'am.
Yes.
Will we be able to see our test two? Is it test two? Yeah, test two marks before we write test 3.
Yes. I'm busy marking them. You will get them probably
Oh,
by Monday.
okay, ma'am.
Yeah.
Thank you.
Okay.
Bye.
Yes.
Miss,
Yes. Yes.
I want to ask about the test 3 that we are going to write. Is
Yes.
it just the same as the tutorial test whereby we only fill in the answers?
Yes. It'll be something similar to that. There might be others where you type a little bit, but majority of it will be filling in the answers. So maybe even a multiple choice test.
Okay, Miss. Thank you, Miss.
But I will still confirm with you guys. So for now, that's what we're looking at, just so that everybody knows their marks before the date, the supplementary test. So that is a possibility that we're looking at. Okay, and the rest of you guys are fine, I hope. Keep marking the assignments. Like I said, you guys are the markers. Now you understand what we go through. It is not easy at all, but you have to do the marking and try and do it to the best of your ability, as honestly as as best as you can. Really try not to penalize somebody unnecessarily while following the memo as much as possible. Okay, so things that, like for example, where I say do not give a mark if the word maximize is left out, that one you should definitely not give them a mark, because your objective must be clear. You don't just say my objective is to profit. No, you want to maximize your profit. That is your objective. Okay, and then the rest.
Ma'am,
Yes, yes.
what if the person's pages are horizontal?
That's what I'm dealing with your test. So what should I do in the test? Maybe then we can decide together. What should I do in a test if somebody's pages are horizontal?
I have no idea, miss.
Ah, you see, that's what I'm dealing with now. So I
Oh,
must turn my head horizontal. I don't know what to do. I would
okay,
say
ma'am.
just mark it.
Okay, ma'am.
Yeah. Okay. So have a good day, and I'll see you guys tomorrow.
Bye, ma'am.